Hey guys, welcome to another lecture from ecopoint. And today I'm starting with a series on Lagrange multiplier for mathematical methods. And we'll kick off with the introduction to optimization using Lagrangian. And this would be very helpful for all of you when it comes to your examination questions. So let's get started. First thing first, why optimization? So optimizing means that you are maximizing or minimizing. Now, most of the time, what happens is that, for example, in economics, we try to maximize utility, but we always have this constraint, the budget constraint, right? And that is why constraint optimization comes into picture. As soon as constraint optimization comes into picture, a very important method, Lagrangian, comes in to help us figure out solution to any constraint optimization problem. Let's say, mathematically speaking, a constraint optimization will look like maximize or minimize, which I'm denoting as max min, which is the usual way of writing. And say we are talking about two input function. So a two variable function fxy, we want to maximize or minimize that subject to a constraint which also consists of these two variables x and y, and the constraint is gxy equal to c. For example, your income is equal to certain number. It could be 10, 20, whatever it could be. So c is that constant. Easiest way to understand it is utility. So suppose we have a utility function uxy. Now, utility is what? Suppose X, Y are these two goods which will give you happiness. So you want to maximize your happiness, right? But you have a constraint. You have a constraint, a certain amount of money that you can spend for this happiness. So UXY is something that you would want to maximize subject to the usual notation for budget constraint P1x plus P2y equal to, say, since uxy is your objective function, and this is your limitation, it's your constraint, like money. So two things give you happiness, but you have limited amount of money. How will you maximize your happiness using that money? To solve this, what we do, we use Lagrangian. Now, what is Lagrangian? Basically, the Lagrange multiplier method is a method to find optimal point where the objective function and the constraint, they're tangent to each other. And that's exactly what happens because you need to satisfy the constraint as well. So whatever optimal you have is maximizing your objective function, satisfying the constraint. So here in what we do, we create Lagrangian L, we are taking X and Y as those goods, and lambda is the Lagrangian multiplier. And this is your Lagrangian, which is equal to fxy, the objective function, plus lambda times lambda, the Lagrange multiplier. So lambda times c minus gxy. So what essentially you're doing is you're combining the constraint and the objective function to create this new function, Lagrange. Now, lambda, which is your Lagrange multiplier, is a variable that helps us balance the objective function and constraint. What do we do? So the steps involved here are as following. So number one, what you will do is you will compute partial derivatives. Since you have two variables, x and y, so what you're going to do is you will find out del L by del x, put that equal to 0. You will find out del L by del y, put it equal to 0, and you will partially differentiate del L upon del lambda and put it equal to 0. What do you think this will give you? If you differentiate with respect to lambda, this will actually give you gxy equals to c. And that has to happen, right? That needs to get satisfied. And then number two, what you're going to do is you will solve this system of equation. You will solve it for x, y, and lambda, because remember, this lambda that you will get, it's a unique lambda to this pair x, y that you will, optimal pair that you will find. And then, of course, you will also counter check that gxy is turning out to be c at the optimum that you are figuring out. Well, the third step basically just lets you be on the right track. Let me give you a very simple example to understand this. Let's maximize xy subject to x plus y equals to 10. One of the very common problems in economics. This is your utility function xy, a very common utility function, and this is your budget constraint. So you have income 10 to spend on x and y together. The first thing that you will do is to understand what is your fxy, it is xy, and understand what is your gxy equal to c is basically x plus y equals to 10. And now you form your Lagrangian. So Lxy lambda is equal to xy plus lambda times c, that is 10, minus x plus y. The next is to follow the steps that I've just told you. The first step, del L by del X equals to 0, and that will give you y minus lambda equals to 0. Second step, del. Then we will differentiate with respect to y, put it equal to 0. When you will do that, partially differentiate with respect to y, you will just have x, and from here you will have minus lambda equals to 0. And then when you will differentiate with respect to lambda and put it equal to 0, you will figure out that 10 minus x plus y is equal to 0. Now, if you observe, what are you getting from here? From here you get lambda equals to y. From here you get lambda equals to x. And from here you get x plus y is equal to 10. So, these two equations actually give you that x is equal to y, right? So, put x equal to y in number 3. So, x plus x equals to 10, which implies 2 times x is equal to 10, which implies x is equal to 5. If x is equal to 5, since x is equal to y is also equal to 5. And with that, we also fetch, because x is equal to y is equal to lambda, lambda is also equal to 5. So what is the solution? Solution is x equal to 5, y equal to 5, and lambda also is equal to 5. What is the maximum value? Maximum value xy is equal to 25, 5 into 5. So you're getting maximum at 5. So think about it. What is this lambda? See, this lambda which turned out to be 5 is basically that value which somehow binds the constraint. Graphically speaking, this is what is the situation in the problem that we took, xy subject to x plus y equals to 10. This is the graph of xy equal to 25, where you're at 5, because at 5 you are getting the maximum, and you can see that 5 is something that will satisfy the constraint as well. Of course, the graph of xy, when it comes to indifference curves, you can take a lot many other curves. You can create curves xy equal to 1, xy equal to 2, xy equal to so on and so forth. Xy equal to 25 is what will touch this budget constraint and give you the optimal value at 5. Why is it so important for you to understand Lagrange, to begin with, to have this knowledge? If you are specifically somebody who's studying economics, think about a situation that you want to go to the market and buy two goods, say X and Y, and you have limited resources. You have 60 rupees with you. You can only spend 60. Suppose you have a utility function, which is, let's say, x to the power 0.5, y to the power 0.5. And you have a suitable budget constraint. Your budget constraint is that 2x plus 3y is equal to 60. Under this situation, Lagrange is something that will be able to give you an optimal value of xy satisfying your budget constraint in a jiffy. In fact, why don't you guys just try out this problem that I just discussed with you, to make you understand why Lagrange is important. Say u is x to the power 0.5, y to the power 0.5, and your budget constraint at 2x plus 3y equals to 60. Try to find out the solution to this, and we can discuss some more questions like this in the next video. Thank you very much for watching.